Okay, today we're going to look at using synthetic division to factor and solve when you're given some information. So you're either going to be given a factor, and a factor looks like this. So a factor would be like an x minus 2, and it's usually in parentheses. Or it's going to give you a root, otherwise known as a zero, so a root or solution, also known as a zero, would usually be given to you as like x equals 2. Okay? So you have to recognize how it's given to you so that you can proceed with synthetic division. So after we do the synthetic division, we saw this in the previous lesson, that we will continue to factor and then solve the polynomial. So we're just using synthetic division to make the polynomial smaller. So what you're going to notice is that you're going to be given a higher degree polynomial. Like this is a third degree polynomial. But this polynomial is not going to be factorable just by itself. So we're going to have to use the given factor to make it smaller, or to create a depressed polynomial so that we can go and factor and solve it after that. So we're going to use all of the strategies that we've been using. We're going to use synthetic division, we're going to use factoring, and we're going to use solving. So all of the stuff that we've learned back from day 1 of Algebra 2 is going to end up in this lesson today. So the first thing we're going to do is set up synthetic division. So our factor, our divisor, is x minus 4. So we're going to use 4, and then our coefficients are 1, 1, negative 14, and negative 24. So we're going to use this in synthetic division to create a depressed polynomial. So we drop the 1. 4 times 1 is 4. 1 and 4 make 5. 4 times 5 is 20. Negative 14 and 20 is 6. And 4 times 6 is 24, giving us a 0 as a remainder. Now, one of the good things you're going to see today is that all of our synthetic division should come out to be remainder 0 because we are factoring the polynomial. All right, so we have used synthetic division to depress the polynomial. We're going to rewrite the polynomial, x squared plus 5x plus 6. That's step 2, and then it says, actually now we're going to write step 2. We're going to factor the polynomial as x plus 2x plus 3, because 2 times 3 is 6, and 2 plus 3 is 5. Now, we're going to move up to the solving part. It says factor it completely. We did that. So we're now going to take the x plus 2. Sorry, that was not supposed to be black. X plus 2, set it equal to 0. X plus 3, set it equal to 0. And we'll quickly solve each one of those as x equals negative 2 and x equals negative 3. So we solve, that was step 2. And now it says write the solution using set notation. So that's using the braces. We have an original solution of 4 that was over here. Remember, we got that from the original factor. And then we just found negative 2 and negative 3. So finish that off with a fancy bracket, otherwise known as a brace. And so what we have done is we have found a couple different things. We found the factorization. We factored the polynomial down here, and factored it here, and we have it solved here. So we've done 2 different things with this problem using synthetic division. We've learned how to factor, and we've learned how to solve. So we now have used synthetic division to help that process. Let's look at another example. So this problem is asking us to factor the polynomial. So when we get done, we want to have as many factors as this problem will allow. So at most, we're going to have 3 factors, unless it doesn't factor further, okay? So we wouldn't want the 4 parentheses down at the bottom, but this is what we're looking for. We're looking for parentheses at the bottom of the problem. So it wants us to use synthetic division with the given factor. So this is the given factor, this is the divisor. So we know already that down here on the bottom, when we get to our answer, we're already going to have x minus 2 as part of the answer, okay? Because it's one of the factors and it's telling us to factor it. So let's look at synthetic division and see how we can whittle this polynomial down a little bit. So we're going to use the x minus 2 to give us a 2 as a root or a 0. The coefficients 1, -3, -40, and 84. Now, a reminder from the previous problem that we're supposed to have a 0 right here. So if we don't get a 0 as a remainder, then we've done something wrong. Alright, so let's drop the 1 down. 2 times 1 is 2. -3 plus 2 is -1. 2 times -1 is -2. So that's -42. 2 times -42 is 84, but it's negative, and we get a remainder 0. So we got the remainder 0 we're supposed to get. Now we're supposed to turn this into the depressed polynomial, x squared minus x minus 42, and then we're supposed to factor that. So this is an easy trinomial, x, 7, 6, because 7 times 6 is 42. The sign on the 7 will be negative, the sign on the 6 is positive, and those two, whoops, I was hoping they were all together, those two finish off our answer because now we have fully factored this problem. X minus 7, x plus 6. So, based on the directions of factoring this problem, this is fully factored. Now, to extend this problem into the next level, now this is not the directions of this problem, but this is where this problem is going. It asks, what are the roots? Roots are another word for x-intercept. Okay, so we would take the x minus 2, we would set it equal to 0. We take the factors, we set it equal to 0. We would say that x equals 2. So 2 would be one of them. We take x minus 7, we set it equal to 0, and x would be 7. So 7 would be one of the roots. And we would take x plus 6 equals 0, and we would say that -6 is a root. So that is the next step of this problem. All right, let's take a look at example 3. So in example 3, you have your divisor. So we can put the -1 into synthetic division. We're going to go ahead down here and set up our answer so that x plus 1 is part of the factorization. We use 2, -3, -17, -12. In synthetic division, we'll bring down the 2. -1 times 2 is -2. It gives us -5. -1 times -5 is +5. Gives us -12. Negative 1 times negative 12 is positive 12, giving us our remainder of 0. So, yay, that worked. Okay, that was the goal. Let's turn that into a quadratic. 2x squared minus 5x minus 12. We need to factor this because the directions are to factor. So, we'll use 2x and x. 2 times, so we'll do 4 times 3. So what that's going to do is it's going to go 2 times 4 is 8. 3 times x is 3. If I subtract those, I'll get 5 that I want in the middle. My 8 needs to be negative, so I'll use negative 4 and positive 3 to completely factor that. So down at the bottom, I will finish up my answer with the factors. 2x plus 3 and x minus 4. Now the extension of this problem says, what are the roots of the equation? So based on the factors of the problem, we would say the roots are, I want green, x equals negative 1 from the first factor, negative 3/2 from the second factor, and positive 4 from the third factor. So you have to know what the directions are asking you for. Are they asking you to factor it, or are they asking you to come up with the roots? So we've actually answered 2 different questions here on example 3. So example number 4 has a new direction. This time it's telling you to find the roots. So that means we have to factor and solve the problem. Previous problems had just asked us to factor it, and we could have stopped at the parentheses. But now we've got to go all the way and find the roots. And it's telling you that one of those roots is 2. So that does 2 things for us. That's the number that goes into our box for synthetic division, and it's one of our answers. So that's part of our answer. Alright, so let's go ahead with continuing our synthetic division. So we use 1, negative 11, 38, and negative 40. So we'll bring down the 1. 1. 2 times 1 is 2. Negative 9. 2 times negative 9 is negative 18, giving us 20. And 2 times 20 is 40, canceling out, giving us a 0 remainder. Perfect. So we turn that into our depressed polynomial. We factor it. This is an easy trinomial, so it shouldn't take long. Minus, oh, I see a problem. Okay, it's positive 20 instead of positive 20. So minus 4x minus 5. And then our answers, this one will be x equals negative 4. So that's a negative 4 we can add to the problem. I'm sorry, positive 4. And this one equals positive 5. So we can add positive 5 to that. So our answer to this problem are the 3 roots, positive 2, positive 4, and positive 5. Now, the extension to this problem says, what are the factors of the equation? And there, 2 of them are sitting right here. So we can just go ahead and say, well, I know 2 of them, x minus 4 and x minus 5 are 2 of the factors. And then we can use the root equaling 2 of the original problem to work backwards and say that we can also have the factor x minus 2. All right, the last example I'm going to work is example 6. And this time, what they've done is they've given you 2 roots. So we're going to have to do synthetic division 2 times. And you notice that we should end up with four answers based on the degree. So we should be able to come down here and say that 2 of our answers are already -5 and -1. And so we just have to find the other 2 answers once we get the synthetic division done. So we'll use -5 first with synthetic division. 1, 6, 3, -12, and -10. So we'll drop the 1. -5 times 1 is -5. The 1. That's another -5. -2. -5 times -2 is +10. Remaining -2. -5 times -2 is +10, giving us the 0 that we want. So yay, first one worked. Now, we're going to do synthetic division with the -1 immediately right now without writing down the next, without creating the depressed polynomial. But what we have is, remember that this started out as x to the 4th, and this was x to the 3rd. So we're continuing to whittle down our polynomial. We're just not writing down the whole polynomial. So we'll bring down the 1. -1 times 1 is -1. That's 0. -1 times 0 is 0. It's -2. -1 times -2 is +2, giving us the 0 that we're looking for. We now write down the depressed polynomial because we don't have anything else to do synthetic division with, and we're at a quadratic state where we can continue to solve. And so with this problem is not going to factor. There's no GCF. It's not difference of squares. It's not sum or difference of cubes. So we just have to continue to solve it. So x squared will equal 2. We'll take the square root of both sides, and we'll get x equals plus minus square root 2, and those become our other 2 answers to finish off the 4th degree polynomial. So that is the finished finding all the roots. The extension to that problem over here says, what are the factors? Well, we have a factor sitting right here at x squared minus 2. That's one of the factors, because after we did all of our synthetic division, that's what we were left with, and we decided that it was not going to factor anymore. We can then take the 2 zeros that it gave us to start the problem with, and we can make factors out of those, which would give us x plus 5 and x plus 1. So those are the factors of the equation. Those 3 factors are the finished factors of that polynomial.